Solar Foods can produce a protein made from thin air. Can you tell us a little bit more about that?
The technology is very similar to beer or wine making. In winemaking, you have a sugars liquid. In a fermenter, you add yeast, and this yeast eats sugar for energy and carbon. And this sugar originates, in the case of wine, from the grapes. What we are doing is also fermentation technology. We also have fermenters, but instead of using sugars and yeast, our microorganism, what is also swimming in a liquid, in a fermenter, it doesn't eat sugar, but it eats small bubbles of carbon dioxide and hydrogen. And hydrogen we can capture from the air with so-called direct air capture technology, and hydrogen we can make by splitting water with electricity.
Mm-hmm. This protein claims to be the purest and most sustainable protein in the world, as I have read on your website. Could this protein be the next big competitor in the meat-free market? What do you think?
Yeah, absolutely. That's definitely what we aim at. And the significant difference, what we do at Solar Foods compared to the existing food system is that we disconnect food production from agriculture. So we're not dependent on the availability of agricultural land, clearing forests for agricultural land, or open land irrigation. 70% of the fresh water used on the planet is actually for irrigation of agricultural land. We don't use pesticides. So when we use this fermentation technology, we disconnect from agriculture and then basically can locate these factories everywhere, but to supply a similar protein that what we are used to have today.
Can you tell us a little bit more about how air and electricity combine in order to give this protein?
What happens is we have our own organism, which is non-modified organism, a microbe that we have separated from environmental samples in a specific way. So it is completely natural organism, but as said, it doesn't eat anything plant-based or biogenic carbon to grow. And this ingredient we can then integrate into different kinds of food products as any protein ingredient or any protein today. So at the end, consumer wouldn't see the difference when they get the consumer product, whether it's something that resembles meat or plant-based dairy or similar, that it has our protein ingredient. It is similar product to those of today.
In terms of cost, do you think that this protein could be very expensive for the average consumer?
No, actually, we are very cost competitive. We already done pre-engineering for our future full-scale factory, and we are cost competitive with plant-based proteins that are cheaper than animal-based proteins. So we are there to compete with animal plant-based proteins.
Mm-hmm. I have read also that the protein is 100 times more climate friendly than meat and 10 times better than plants. Is it right?
Yeah, that's correct. Of course, those who understand life cycle analysis know that there are very large error bars. So depending what kind of meat and which country, what are the specific conditions, but as a global average, this is exactly the case.
How about the taste of this protein? How can you describe it?
The food chemists and food product developers say the taste is neutral, which means that there is no taste. If you added a lot to some neutral base, if you, for example, make a pancake, you add our ingredient, you taste similar things when you would taste when you add egg, for example, to a dough. And if you increase the amount even further, some say they taste a bit of carrot. Our organism is yellow and has some similarities to carrots in a nutritional value. So that is something what you could taste, but neutral, not really any specific taste is the one it mostly has.
Is it true that it is something like a powder that can be vanishes into our meal without losing any of its nutritional value?
Yeah, that's correct.
Yeah, how could you describe it?
Yeah, actually, I have the powder right here. So it is a very fine powder. The organisms itself, and this powder is about 65% protein, 20% carbs, and 10 to 15% fat. So on dry mass basis, it is almost identical to dried soy, and also the amino acid profile is very similar to that of soy.
When it is expected to see the large-scale production of this protein? What are your plans?
We are now actually raising funding for our go-to-market plan, and we plan to be on the market year very late 21, or rather 2022. This is a novel food. We do need a novel food approval in the European Union and globally, or whichever country you go to market. We need to prove that it's good for human consumption. That takes some time. And after a demonstration phase, 2022, we gather the experience, collect the experience from there, and plan to go for a full-scale factory in 24-25.
Pasi, thank you very much for your time. It was really a pleasure talking to you.
Thank you very much.